using an x as the variable. There may be more than one way to, one correct answer. Okay, so basically what you do with these, and I know a lot of students have trouble with these, is you think about a word description and you just do x such that in number 30 we are given a word description. X is an even natural number. So what I'm doing is saying the set of all x such that x is, and then I'm taking this part, the part right here, from the word description. So it is fairly easy once you get the method down. Let's do one more of these. 32, we have 35, 40, 45, all the way up to 95. So what we have to think about, what would be the word descriptions? Well, those are multiples of 5 between 30 and 100, okay, would be one way to think of it. So x such that x is a multiple of 5 between 30 and 100. Now notice you could also say set of all x such that x is a multiple of 5 between 34 and 96. That would also be acceptable. So that's why they say there may be more than one answer. Now we're doing word descriptions. So we practiced that a little bit with 30 and 32. In 34, we have 1, 1/2, 1/3, 1/4. How can we describe those? Well, it looks like in the numerator we always have a 1. In the denominator we have 1, 2, 3, 4, 5, and so forth. So let's see. We could call that the set of positive. All of them are positive. And because they're fractions, we'll call them rational numbers. With a numerator of 1. And 36. We have Alaska, California, Hawaii, Oregon, and Washington. Let's see, that's all the states that border the Pacific. The set of U.S. states that border the Pacific Ocean. We'll go ahead and put ocean in there. Okay, next we're identifying the sets as either finite or infinite. Let's look at 38. 38 has 3 elements. We can count them, so it's finite. And 40, we have dots going in 2 directions, so it continues on, so we can't count them, be infinite. Or we could say the cardinal number is something other than a whole number. Natural numbers less than 50 would be 1, 2, 3, 4, 5, all the way up to 50. So I can count those. They're 50, so that's finite. 44, x such that x is a rational number between 0 and 1. Let me put this one here. Okay, and if we think about this, 0 and 1. 1/2 is between them. 1/4 is between those two. 1/8. 1/16. 1/32. 1/64. 1/128th, and so forth. We can continue on, and I'm not even including all the possible points. I'm just talking about between two given points, I'm finding an additional point. So we can see this is going to be infinite. There's no way we could list them all. Okay. My book to stop. Okay. All right. Let's go to the number of A, find the cardinal number for each set. In 46, we count, we have a -3, so 1, 2, 3, 4, 5, 6, 7. N of A is the number of elements, and there are 7. Let's look at 48. Let's see, we have 1 through 3,000 gives us 3,000. The 0 gives us 1 additional, so the number in A is 3001. Okay, and number 50, the set of all x such that x is a vowel in the English alphabet. A, E, I, O, U. We don't worry about, and sometimes Y. We'll just do the 5. I avoid questions like that on tests because I think it can be confusing. Okay, number 52. The set of sanctioned U.S. Senate seats, there's 2 per state times 50 states. So N of A would be 100. 54. All right, we have 2 for each. If you we have a positive and a negative for each of 9 numbers, 2 through 10. So that's 18. If they had put a 1 and a -1 in there, we'd have had 20. But in this case, we don't have the 1 and -1, so we have only 18. All right, let's skip down to 58. We want to know whether the set is well defined or not defined. In 58, we have the set of all x such that x is a good athlete. Good is a word. It's one person may say an athlete is good and someone else may say the person is not good, so that would not be well defined. It's not clear who would belong to that set. All right, number 60. Set of all x such that x is a counting number less than 2. Definitely we know whether or not something belongs to that set, so it is well defined. All right. In 62, fill in each blank with is an element of or is not an element of. 62 is not an element of. -4 is not an element of that set. 64, 0 is an element of the set to the right. 66 is not an element of, because of the fact that we would have to have this in order for it to be an element of, so that you would have 6 and 7. Okay, then they're elements. You could notice in the case of what they gave, 6 is an element of the set containing 5 plus 1, 6 plus 1. Okay, but the set containing 6, that's the part that makes it is not an element of. A little bit tricky on us there. All right, let's move down to number 70. Right, true or false. 6 is an element of the set to the right is false. 72. M is an element of the set to the right is true. 74. 2 is not an element of the set to the right. That's true. 76. The set containing E, H, A, and N is equal to the set containing A, H, E, and N. That's true. Number 80, we'll skip down to that one. The set 4 is an element of the set containing the set of 3, the set containing 4, the set containing 5. And that's false, for the very reason that we talked about back up here. Okay, let's look down to the next group. 84 says that 8 is an element of B. So if we look at set B, 8 is an element. That's true. And 86, 8 is not an element of B, would be false. Okay, so I think that pretty well covers what you need to know for this section. So your next step would be to go to my math lab and do the online homework.